sir.
Thank you. And we'll be starting in the next few minutes. So before I start, I'll just like to use this time to know if you have any questions with respect to the last class we had. I'd like to answer these questions now. If there's no other questions, there's no question from the last class. Then move to what we have for today. So if you have another question, can you just from the last class, can you just give me a thumbs up on the chat so I can uh, pick that up, or we can just go ahead and then type in your question from the chat, and then I'll pick it up from there. All right. Okay. It's uh 2 minutes gone, so we are starting now. All right, so in the last class, we talked about microcontrollers, and we were able to look at some microcontrollers. We look at Arduino, and certainly we're able to see what Arduino can do, what it can do, what are the components of the little microcontroller called Arduino, and what it can be used for. So now, in IoT, Arduino is just the microcontroller that does like the brain, or can I say the computer behind it. But it's not only Arduino that is used in IoT. There are other microcontrollers that we can use. Talking about the 8085, talking about the PIC, as the case may be. Now, but there is one thing that makes it that gives access. There's one thing that makes it an IoT. And what is that? Being able to connect your device or your project to the internet. That's what makes it IoT. For example, you are designing a, let's just see, a motion sensor, and then you want it to be seen via the internet. What do? You connect it to the internet. And with that, it gives the device full privilege to be act as an IoT device. So today we'll be looking at Wi-Fi module, and then we'll pick up a particular Wi-Fi module called the ESP8266, and then we are going to talk about it. Okay. Just like we talked about that, we are going to pick up the ESP8266 and talk about it. Now, what we are going to look at today, we have an outline of what we are going to look at, the agenda for what we'll be learning today. We'll talk about what a Wi-Fi module is, and then we're also going to talk about how Wi-Fi works, because you need to know how they work before you are able to use them, or before you're able to make good use of them. And then after that, we're going to look at the ESP8266. We'll look at it as a microcontroller, and then we also try to look at it as a Wi-Fi module. All right. Then we'll look at how can we connect, how do they connect? Okay, how can we make use of the ESP8266? How can we connect it to the internet to give us what we're looking for? We're going to look at the different modes of operations of the ESP8266. and then we are going to look at how we can set it, what each mode stands for, and how we can make a good use of it. Then after that, we're going to look at the EC86 architecture. So what is underneath it? Okay, just like we look at the Arduino architecture. So with that, now we know what each particular pin, what each pin can do, and how we can make good use of each pin. So we are going to look at that today, and then we are going to look at general applications of the ESP 8266. So that's the agenda for our class today, and then we are going to move into that. So looking at this now, the first thing is what really is what is a Wi-Fi module. Now, before you're able to define what Wi-Fi module is, you should be able to understand first what Wi-Fi itself is. Okay, because when you're able to understand what Wi-Fi is, that's when you're able to know what a module is. Okay, a module is basically something that gives you full privilege to a particular thing. Okay, so excuse me. So we're going to look at what Wi-Fi is, and then we said that Wi-Fi is actually an acronym. Okay, which stands for wireless fidelity. All right, it's an acronym, stands for wireless fidelity. So Wi-Fi basically is a family of wireless network protocols. Okay, and then it's based on the IEEE 82.11 family. Now I'm going to come back to this. I'm going to come back to this point. I'm going to come back here and then talk about it. I mean this 8012. I'm going to come back here and talk about this a lot because there are a lot of things we need to understand. Okay, so Wi-Fi is just a family of wireless network protocol based on the IEEE 82.11 of family. So and then that's the standard for it anyway. And then it's commonly used for wireless networking, being used for local area networking, device-to-device communication, internet access, being able to exchange data from one particular device to another, and being able to this done via a radio wave anyway. So what happened is that this Wi-Fi has become an integral part uh, of our lives in the 21st century. Everything we do now, it's like our everyday life. Wi-Fi is like everything to us now. Things we need to do, we connected via Wi-Fi. Our vehicles are now Wi-Fi enabled. Our TVs are now smart, being Wi-Fi enabled. A lot of things of rich watches, they are now Wi-Fi enabled, and then you're able to make communications as fast as you want. Now, thanks to wireless fidelity, we no longer have to gather around, okay, to be connected to the internet via cable. Or like a long time ago, when you want to browse, you have to go to a cyber cafe, and then they'll give you a particular cable, either Cat5 or Cat6 cable. You connect it to your device, and then that's how you browse. So people no longer cables are no longer useful anywhere you are, and because of the limitations of cable, the length, the size, and quality, you are confined to a particular spot. So you can't move around and still do what you want to do. The Wi-Fi now gives you the ability to move around and then you still do what you want to do. There's no ages anywhere. You still do whatever you want to do. So that's just one of the great advantage of this. But come to think of it, have you ever wondered how this Wi-Fi really works? Like, have you asked yourself how do they work? Okay, So we're going to talk about that in we're going to talk about that. But in today's class, we're not going to deal too deep on Wi-Fi. There is a topic in this curriculum that we're going to deal extensively on Wi-Fi, and then we're going to break it down chunk by chunk. But today, we'll just see how we can do a summary, just an overview of this. So now look at this diagram. Okay, look at this diagram. And then I got this diagram online. So what can you say about this diagram? Now, this is just an example of a smart home. Okay, this is just an example of a smart home. You have all the sensors connected to each other. You have the motion sensor there that is Wi-Fi enabled. Okay, you have a motion sensor there which is Wi-Fi enabled, and then you have the environmental monitor there which checks your temperature and everything. Also Wi-Fi enabled. You have the door control, Wi-Fi enabled. You have the remote control, which is Wi-Fi enabled, and a whole lot of things. The temperature monitoring. You have the alarm. You have the window control. You have the lighting. Okay, you have the lighting, and all of these are connected together. And this is the main thing about smart. This is the main thing about smart home, that you are somewhere and you're able to control your gadget at home, and then you don't have much issue. Just go there and then control whatever you want. So this is just an overview of a smart home. These are controlled by Wi-Fi, all right? Although they are microcontrollers, some of them has microcontrollers underneath that does whole calculations and does the whole calculation in general, and then does the whole computing aspect of it. But the Wi-Fi takes that particular information and then sends that information maybe to maybe you have a hub. Okay, a hub is just basically a hub or a node. It's just basically interconnections of different devices connected together. It can be wired, it can be wireless. Okay, so you have your home, you have your TV. There are a lot of TVs now are smart, so you can just maybe you can stream YouTube videos on your TV. You can do whatever you want to do on your TV. Some of them are even Android enabled. You can just play games, online games, and then you have no issues with that. So that this is just an example of what a smart home is all about, and it's all controlled by Wi-Fi. So you that wants to learn IoT, Internet of Things, all right, you really need to understand how the Wi-Fi works and how the internet works. So you'll be able to know how you're able to send information and how you're able to receive information. So now, what is a Wi-Fi module? So a Wi-Fi module is also known as a wireless LAN area network. So it's just electronic component which is used in many products to achieve the wireless connection to internet. All right. Remember we talked about the IEEE 82.11. So you can see it at the bottom of this particular module I'm putting up here. So we are going to talk about it later on. But now take a look at I had to put up some different Wi-Fi modules out here for you to see. And these ones are from the company called Expressive. Okay, Expressive, the one of the leading IET or Wi-Fi modules. Okay, right now they are one of the leading Wi-Fi modules. So if you're doing IET, okay, you can make use of these. Okay, and then some of their devices are open source. Some of their components are open source, so you can pick it up and then modify it. I've designed some IoT device. I've designed some Wi-Fi modules personally, and then I've used them in my project. Mostly the ones I use in my project are the ones I design myself. So you have the ESP11. You have ESP11 here. You have the ESP12, ESP12E. You have the ESP12F, ESP13. You have the ESP01. You have the 01, 02, 03. As a case, there are a lot of them. Okay, there are a lot of them out there. So you just need to know which one. Now, the reason I had to bring out all of these for you to see is that they have their advantages, okay, and they have their disadvantages, okay. Some of them have a greater pin, okay, higher greater pin than the other. Some of them can accommodate a lot of things than the other. So before you design a particular device, you first have to know what really you want and what that device is going to do. What will be your the data? What type of data will it be sending? Okay, and what type of data will it be receiving? So with that, it will help you know which type of module you are going to get, or what are you calculating? All right, okay, what are you sensing? So there are some of them that you can really use them for an analog device. Okay, for example, you want to read a physical quantity, something like temperature. Okay, there are some of these devices that it can't really be useful. They are not really good at that. Okay. I think there is one I didn't include here. That's the ESP node MTU. Okay. That one has just one analog input, just one analog input, which is the A0. So meaning that you can include a lot of analog signals. You can include a lot of analog signals into it. You only have just one pin for analog signals. So with that, you know, okay, which microcontroller is the best for me. Now, secondly, some of them have an onboard antenna, some of them do not have an onboard antenna. So now those who have onboard antenna, they are kind of limited. Have a kind of they kind of have some limited distance anyway. They kind of have a kind of a limited distance anyway. But those like these ESP 078, it has an external antenna. Which other one? I think ESP32 is not here. ESP32, if you look at the AI Think version of ESP32, it has an external antenna in which you connect to it, and then you can get it can give you some kilometers radius, okay, based on the strength or the power of your transmission. We're going to talk about the power of transmission. We're going to look at that later on. And then those that have onboard antennas, well, you can't really go that far. It's just going to be within a particular environment. So, for example, there is a socket I designed some time ago, just for domestic use, and then I was using the 01. Okay, so I was using the 01, and then it wasn't that far. So there are some points that you can get the Wi-Fi connection. So you have to make it very close to the hub, like in the router, so you could get internet access. So the big question is, okay, the big question is which you're going to answer at the chat menu there. So the question I'm going to ask now is, this very USB Wi-Fi device, is it a module? Okay, can you say that this Wi-Fi device now is a module? This very one up here, can you say it's a module? Yes, we said it's a module because it just added it gives it, okay, it makes it gives you privilege, okay, to the internet. Okay, just an attachment that gives you privilege to the internet. So you have this in your laptop, you have Wi-Fi modules in your phone, you have Wi-Fi modules in your laptop, and then most of them has two cables that are connected as antennas, and then they tell you, okay, before you're able to see this, you have to do this and do that before you're able to connect to the Wi-Fi, or maybe change your Wi-Fi module or other stuff. So yeah, it's also a Wi-Fi module. There are other ones out there. So you got to know which one is best for you. It's a USB version very good for you, depending on what you want to do, or pin all these pin all those pin sensors. If they are best for you, you just need to know which one is best for you to use. So let's look at how these devices, how really they work. Okay, how do Wi-Fi work? Because it's a question for a lot of people ask. It's not just picking up a device. Okay, it's not just picking up a device and then you going through something. How do these device work, and how can you make use of these devices? So that's what we are going to look at right now. So now, the Wi-Fi, okay, the Wi-Fi itself uses radio wave, just like I talked about in the earlier slide. It uses a radio wave to transmit information. All right. So it transmits this information between your device and maybe probably a router. Okay. So now a router just maybe a device that gives you access to the and maybe gives you internet connection and everything. Okay. It has a hotspot and it broadcasts. Router just basically something that broadcasts Wi-Fi anywhere. So Wi-Fi uses radio frequency, radio wave to transmit information between your device and a router. All right. So now this basically it has two radio frequencies. Okay, two radio wave frequencies, and which can be used. Okay, depending on the amount of data that is being sent and received. All right. Now for Wi-Fi, we have the 2.4 gigahertz Wi-Fi. Okay, we have the 2.4 gigahertz Wi-Fi, which is this. Okay, and then we have this, and then we also have the 5 gigahertz Wi-Fi. All right, so it helps you, it just gives you, it tells you what you want to do, and it just tells you what data you want to control and which one you don't want to control. All right. So the 2. Now the thing is that what does this 2.4 gigahertz mean? All right. You can see there in that me writing the 2.4 gigahertz, the strength, and then you can look at the strength range, and then you can talk about the accessibility and fast. Okay. Now if you want to look at the gaps, okay, let's look at this actually before I give you an in-depth analogy of this. Now, just begin to look at this 2.4 gigahertz. Now, look at the gap in between these, okay, between each wave. All right. Look at this gap, and then look at the gap in between this wave and the next wave. Look at the gap in between them, and look at the 5G, the gap in between each of them. Now, let me explain this waveform when it as in terms of let's look at let's look at the water now, or let's say you went to a beach or you went to stream, and then let's just say there is a disturbance in the water. All right, and then you see the wave. Okay, the way the water goes up and down and all those stuff. Okay, those are waves. Okay, so for it to complete, okay, from a start to finish, we'll say that it's one cycle. Okay, wave has it's always soda. Okay, so it has a 4 quadrant, the first 2 quadrants which are positive, and the other 2 quadrants which are negative. So for it to complete this cycle, we say for it to complete it, we say it has completed one cycle, and one cycle is basically 1 second. So when we talk about 2.4 gigahertz, we are talking about this waveform being able to transmit at 2 point like let's just say 2,400 2,400 million times in a second, if I'm not mistaken. All right, so it's like 2,400 millions per second. And then if you look at the 5 gigahertz part, we are talking about 5,000 million wave, okay, in a second. So it goes way too fast. So now, well, we've just talked about the hex, how the hex is measured and how it's talked about. So let's look at this. Let's look at this in depth, and then now these two frequencies, okay, these two Wi-Fi frequencies are split into multiple channels. Okay, now the 2.4 gigahertz uses about 11 channels, and then the 5 gigahertz uses about, I think, 20 something. There are 23 or 24 channels, even I'm mistaken. So now they split into different multiple channels. Okay, so the reason they split into different channels is so that they can prevent high traffic and interference. All right. So when it comes to sharing data across channel, well, that's just the magic in computer science anyway. But this is what happens. In the first step, it's going to process. The first step is the process. The process initiated by you, the user, anyway. Maybe you do a browsing, or maybe you Google something. So that's the first. That's the very first step, anyway. So it's done by you. So when you access the internet on your device, maybe your laptop or maybe your phone, now this is what happens. It converts that information you have requested. Maybe you have that you are maybe whatever you've requested for the information you've requested is going to convert that information into binary code. Now, remember when we started this class, we said that computers understand binary codes, which are zeros and ones. So it's going to convert that instruction, that information in which you requested for, into zeros and ones, which is a language that computers understand. Now, everything computers do is based on binary. All right, so it's just ones and zeros, ones and zeros. The button you click, the keyboard you type, or everything you do is just based on ones and zeros anyway. So when you click on a particular article, all right, maybe you click on a particular video to watch, like maybe sometime you'll be watching this video on a YouTube. So when you click on that particular, when you click on a particular article, or maybe now this is what happens. That particular request you made is being translated into a series of ones and zeros. Okay, a lot of ones and zeros. So now, if you're using Wi-Fi, that if you're connecting to a router via a Wi-Fi, this is what is going to happen. These ones and zeros will now be translated into wave frequency, either the 2.4 gigahertz wave frequency or the 5 gigahertz wave frequency. So the ones and zeros that you had requested for, which was converted to you, is now going to be translated into this waveform. So which is going to be carried by the Wi-Fi chip, all right, which is embedded or in your device. Now, this particular frequency travels across the radio channels I had mentioned earlier, from whatever any channel you're connected to. So it's going to be it's going to travel across devices that are connected to any of those channels. And now this is going to be received by your Wi-Fi router that your device is being connected to. Like right now, this presentation I'm making, I have a Wi-Fi at home where my laptop is being connected to, my gadget at home is being connected to, and basically my house is being connected to. Well, I'm careful of using some keywords because my house is going to pick some keywords up. All right. So what is going to happen is that the device is going to translate that information. It's going to translate that information. It's going to just translate that information into the waveform, like I said, and then it's going to be carried by the frequency that your device, your Wi-Fi frequency, which is embedded in your device. Now, what happens is that the router then converts that particular frequency back into binary code. All right. When I talk about binary codes, I'm talking about ones and zeros. And then when once it translates it back to binary code, now this is what happens. They translate what's going to it's going to translate that particular code into the internet traffic that you have requested for, or maybe the request that you made. Now I'm going to transfer it back, and then the router receives that data through maybe a hardwire cable or whatever thing that is being processed is being used to give it internet. Maybe you're using network provider ISP or whatever you're using to send to give it internet. Now the process is going to repeat itself until until the article that you've requested for is completely loaded on your device. Okay, so it's going to keep on sending data. You don't keep on sending data. So like here now, it's going to keep on sending data till you get what you're looking for. Okay, it goes like this animation now. It's going to keep on sending this till you get what you're looking for. So now look at this other picture. So this is a computer now. So this computer wants to send data to this printer for this printer to print. So, and this printer is connected to a router, okay, So they are in the same network. So what happens is that the computer now sends an information to the router. The router picks that information, translates into series of ones and zeros. Okay. When it translates it to series of ones and zeros, it now sends it to the printer. The printer now gets those ones and zeros. The printer now gets those data. Now, before this data is now sent here, it has been translated back into what was requested for, okay, to be printed. So, and then you have your device, you have whatever you're printing coming out for you. So it's just the same. It's the same. This same process happens in laptops. It happens with mobile phones. It happens with smart TVs. It happens with probably anything that connects to the internet. So it connects. It applies to anything that requires internet access and everything. So now all this happens at a very fast rate. Okay. Now you'll be hearing your network provider saying that they are giving you some speed of browsing. They said they're giving you some bits per second and some other stuff per second. So now this travels at a very fast rate. So you can't really see it, and then you load a particular URL and like when you want to check for its responsiveness, and it's like, and maybe hey, it's loading in maybe in like 1 second or 2 seconds. You're like, whoa, it's fast. Yes, it's fast, but there is something. There are frequencies that there are things that send those data. There are a lot of ones and zeros entering and going out of your device, and some of them goes way up to like 54 megabits per second. That's very fast. Some of them goes up to that very very fast. Now, when you talk about 54 megabits per second, now it means that that particular router has the ability to transmit binary data like 54 million ones and zeros are going into your computer and going out in a single second. Like in just 1 second, zeros are going in and out of your computer in like a second. So that is very very fast. Am I correct? That is very fast. So that is just a brief discussion, okay, of how this Wi-Fi works, and it happens very fast. You don't really notice. You are doing a chat and then you just send someone a message, and like instantly the person is receiving that message over the other way, or maybe you said something to your TV, and before you are done saying a particular thing, your TV already is on, or maybe you want to turn on your fridge or your socket. I'm not going to say the word now, because if I use Google keyword, my device down here, they are going to start working. So it's very very fast, and because they are connected together. All right. So now let's look at the ESP8266. Let's look at the ESP8266 now. So now the ESP8266, the ESP8266 is a Wi-Fi module. All right. We use it a lot in IoT. Okay. Anything you want to do, you want to send information to somewhere, you want to connect something, you just have to very fast. Yeah, excuse me. So it's a Wi-Fi module, and then you can see down here, you can see here this written on it. I hope you can see this very clear. Let me pick up my pin. Okay, hope you can see this. All right, this is the main chip. Okay, this is the main chip, and this is designed by Expressive. Okay, and this is ESP826601S. Okay, this is ESP826601S, and then it has just about just 8 pins, and then 2 for power. It takes just 3.3 volts. Please do not give it anything greater than 3.3 volts, because it's very very sensitive. Okay. If you don't really know how to work with voltage and current, we're going to treat that in the next class. We're going to talk about voltage and current.
and then we're also going to talk about sensors and how we can connect them anywhere. So if you don't know how to connect it, I wouldn't advise you to go to it because it's very fragile. It can easily fry up. So okay, so talking about the ESP8266 is ESP8266 is a Wi-Fi module, and then it has a self-contained SoC. When I talk about SoC, I'm talking about system on chip. System on chip is I wouldn't really call it a microcontroller. Well, I wouldn't really call it a microcontroller, but anyway, it somehow to some extent acts like a microcontroller anyway because it has a RAM, it has a RAM, it has some memory anywhere where you write where some programs are saved, and then it does some calculations anyway. It does some computations anyway. So, but I wouldn't really call it a microcontroller. Sure. To some extent is a microcontroller. So now this SoC is integrated with TCP. Okay. Now we are going to talk about this TCP very deeply. TCP really basically stands for Transmission Control Protocol, and then the IP there stands for Internet Protocol. All right. So when we start talking about communication protocols in IoT, we are going to deal in depthly. We're going to talk in depthly on these TCPs and IP. So there are a lot of protocols and communication styles in which you can use in IoT. There are a lot of them. Yeah, way more. So depends on what you want to do. You choose which one is best for a particular scenario. Some are good in short range communication. Some are not really good for short range communication. So you need to know. And some are good when you have maybe when it's a peer-to-peer device, like one device talking to another device, not like one device talking to multiple devices. All right. So some are good when it comes to peer-to-peer. Some are not good when it comes to peer-to-peer anyway. So we're going to talk about that later on. So now it's integrated on a TCP IP protocol stack that gives any microcontroller access to Wi-Fi network. So the thing there is that you find a lot of people connecting it, interfacing it with Arduino. Now the thing is that it doesn't have lots of functions. Okay, doesn't have a lot of functions, a lot of pins, GPIO pins on it, and then Arduino has lots of GPIO pins. Okay, so that's why a lot of people use interfacing with Arduino in order to do some functions anyway. So going further, when we start talking about the architecture and the pinout of this particular microcontroller, we're going to see that not all GPIO pins not all GPIO pins are good for input. Some are not very good for input. Some are some are good for output only. Some are not really good with input. So though they are called GPIO pins, but anyway, but I don't know why I'm still getting to know that a lot when it comes to ESP8266. That I'm talking about the Node MCU version of this. All right. So now the ESP8266 is capable of either hosting an application or of loading all Wi-Fi networking functions from another application processor. So when I say that it's capable of hosting an application, I mean that you can write your own application, you can write your own program into it. All right. There are some, if you're basically looking for some switches, some on and off programs, I don't think there is a need of you having some an external micro controller, except you're dealing with a lot of GPIO pins. But if you're dealing with just maybe 4 GPIO, with just basically 4 GPIO pins, this small bit very mighty device, this device can do that great work for you. Okay, if you're not dealing with a lot of pins, okay, this small device can do that work for you. So you can host your application there. You can write programs directly to it. In this, the course of this program, you're going to see how we are going to write programs into ESP. You're going to write programs into it, and then we are going to see how we can connect to the internet, and then we're going to see how we can make use of it accessibility. Right. So each ESP8266 module comes with a pre-programmed. It comes pre-programmed with an AC command which has with the 80 command set firmware. Now, the thing is that the main important of this 80 command set firmware is that you can simply hook up your Arduino device with this particular this particular board, and it's going to act like a Wi-Fi shield, okay, like a shield for you. Or maybe you can easily write a program that fits it, and then it runs. All right. So there are a lot of things. There are a lot of things in this particular device. So that's just a very brief introduction about that. So if we want to go further into this particular device, okay, if you want to go further into this particular device, we are going to see a whole lot of things in it anyway. And then when we talk about a whole lot of things, we're going to talk about the devices, the devices, the microcontrollers they carry, and what they are going to do. So now, okay, so talking about the TCP, TCP and IP. All right, let me just do a little. Let me just touch that a little. So TCP and IP, okay, protocols is a suite for communication protocols. Okay, basically used to interconnect network devices on the internet. All right, so it's like I said, is a communication protocol, okay, used to interconnect network devices on the internet. So now it can also be, this TCP and IP can also be used as communication protocols in a private network. Okay, when we talk about private network, I'm talking about something like maybe an intranet or an extranet or whatever, it is. Okay, so now the entire IP suite is a set of rules and procedure which is commonly referred to maybe TCP or IP, and then these are two main protocols. Okay, there are two main protocols, though others though they kind of interrelated. Some people kind of include this one in this one, but they are just protocols. Okay, the TCP and IP, they're just the IP is just a different protocol, and the TCP is just a different protocol on its own. Like for example, maybe you can decide to write a socket interface. Okay, maybe a socket program. When I talk about a socket program, you're trying to use an IP address, and a port, okay, to send information of, okay, to a particular device, to another device. Now, this device has to be on the same network before they are able to communicate with each other. So just have to pick up the IP address of this part. If you like, say for example, I have a computer A, and then I want to talk to there's a computer B, and all of them are connected to the same network. So all I just have to do is that I just need the IP address of computer B and the port of computer B, and then I can broadcast my message to computer B, and then computer B will just receive it. Will just receive that very information. So the TCP and IP kind of specify how data is exchanged over the internet by providing an end-to-end communication that identifies how it should be broken into packages. Okay, when I talk about packages, we have address, we have transmitted routes, and every other thing. All right. So now, maybe the received destination. Okay, maybe maybe how it's being received at the other destination. So it requires a kind of central management, and it is designed to make networks reliable with the ability to recover automatically from failure of any maybe device. Maybe there's any network failure, or maybe you're trying to send something or not able to get something, and then it just gives the ability to recover very fast. So the TCP kind of defines how application can create channels of communication across a particular network. So I'm breaking down the TCP. So the TCP kind of identifies or kind of defines how applications can create channels of communication across a particular network. Now it also manage how a message is assembled into smaller packages. Okay, remember I talked about zeros and ones anyway. It also tells you how the messages are being managed in smaller packages before they are being transmitted over the internet, and then they are being reassembled at the destination in, and then so that you can get the full message of what you request for. Then the IP defines how to address and route each of those packages to make sure it reaches the right destination. So while TCP talks about how you manage, how you write this information, just look at it in this particular just look at it this other way. Let me use analogy. You have maybe you write a letter and then you send. Okay, so they just see your TCP as that just that channel in which you write the letter and you send that particular letter. So see your this thing, see your TCP at that particular angle, and then see your IP as the gateway. Okay, like the package or a kind of maybe you're sending it through a particular courier service, and then they make sure that it reaches the right destination. So they're going to give you an information. Okay, this was the address you put, and this is the phone number of the person you put to receive this particular letter. They're going to make sure that it reaches that particular address, and the person, maybe the person with that such ID, gets that particular letter. So see your IP address as that. So if you're going to see it a lot in IoT, you're going to make use of it in IoT a lot, and then it helps you communicate between these devices. So when we get to protocols, we're going to talk about it, and then we're going to talk about the HTTP protocols. Okay, it has a lot of protocols. The TCP and IP has HTTP, and then they has HTTPS, which is the HTTP secure. Okay, and then we're going to see how really it works when it comes to client saver. When it talks about clients, we talk about savers, we talk about different things. Okay, so we're going to talk about that in maybe the next in the next class, and then we're also going to talk about layers. Now I'm going to give you this assignment I'm going to also drop it in the channel. I want you to go look at the layers, the application layers of the OSI. I'm going to drop it there. Just go read about it, and then it's going to give you an in-depth knowledge of how the thing works. So when once we start talking about it, you won't be, it's not going to be like a new thing to you. Like you have like the transport layer out there, you have the application layer out there, you have the network layer out there, you have the physical layer out there. You have there are about 7 out there, about 7 layers in the OSI. All right. So that's just briefly about the TCP, and then we are going to talk about that in the next class. So, okay, so now let's look at some specifications. Okay, let's look at some specifications of this particular ESP H266. Now, when I talk about specification of the ESP H266, I'm talking about what it carries and what are the functionalities, what it can do, and what it cannot really do. So what are those things? Just like we talked about it the other way around. So now remember I talked about the 11 I talked about the 11 the 80211. I talked about it when we started this particular class, and then I said that I'm going to talk more about this. So now, looking at the 11 82.11. Now you have B, you have G, you have N, you have B version, you have B version, you have G version, you have N version. So now these are different certifications, okay, and this came in different times, okay, different years. They're all improvements on how Wi-Fi really works. So now, not all of them carries the 5G. So, for example, your phone, not all of your phone carries not all of your phone have the ability to say 5G. So just the recent phone has the ability to see 5G Wi-Fi. So some older phones some older phones anywhere doesn't really have the ability. Let's just say from 2015 down, or is it 2015 down? Yeah, I would say from 2015 down, or maybe from 2013 down. I'm just saying, most of them from 2013 down, from 2015 down doesn't really have access to uh, 5G. They don't their Wi-Fi. The highest you can see is the Wi-Fi. What you're going to see there is going to be 2.4 gigahertz. You're not going to see 5 gigahertz. Now, when I talk about the 2.5 gigahertz and the 5 gigahertz, these, like I said previously, is just different speed at which they are able to transmit information. They're just different speeds at which they're able to transmit information. Now, the 5 gigahertz bandwidth has a maximum range of about maybe 200 feet, like about 200 feet. I'm talking about maybe about 61 meters. Okay, it has, I believe, that's at that range. Okay, but in real world, okay, it's kind of prone to some interference and some other stuff anyway, from maybe walls and so maybe doors and maybe some other objects and everything. Okay. Then the 2.4 band may be a little bit faster for some users connecting to that particular route because of several rooms. It gives some several rooms anyway. But the 5G is way faster than the 2.4 anyway. It's way faster than 2.4. So now the Wi-Fi uses the 82.11 networking standard. It's a networking standard which is being given by the IEEE. So all Wi-Fi makes use of any of those particular standards. Okay, so it comes in different parts, and then you have the 82.11b. Okay, now the 82.11b came out in around 1990. All right, came out around 1999. Yes, it came out around 1999. So it's kind of the slowest, and it's like the slowest. All right, it's the slowest and least expensive standard. All right, it's not expensive. You can easily get it with some just few cents. You can just get that in few cents anyway. It's not that expensive anyway. So it's very slow, like I said, very slow. Now for a while, it's not very popular for a while because most devices doesn't really make use of it. Doesn't make use of it anyway. So it comes it's very slow in what it's doing. So it came in around, that was around 1999 anyway. So it's very slow. And then but it has less, it's kind of common, and it's kind of comparing with it uses a 2.4 gigahertz frequency band anyway of the radio spectrum, and then it can handle up to 11 megabits of data per second. Okay, it approximate maximum speed is about 11 megabits per second. So if you're using that, there's some data that they can really transmit with that. All right. So, and then one thing you really need to understand is that it uses a complementary code key. Okay. It's a kind of modulation that will improve speed anyway. So you can take that down and check that up later on. Complementary code keying. So it makes use of that. It's the acronym is just CCK. All right. So now after that, the next one that came up after the 82.11b is the 82.11a. All right. The 82.11a was introduced after the 82.11b. So this 82.11a has the ability to transmit 5G. Okay. It can, if you're using it as a standard or as a client, you can get connected to 5G network, But if you're using it as an access point, okay, you can it can broadcast 5G to other networks anyway. So the ESP8266 has the ability to broadcast 2.4 gigahertz, and also has the ability to broadcast up to 5 gigahertz. So it has way more. It has very, very big features. So now, when I talk about 5G, I'm talking about that it has the speed of about 54 megabits per second, and then it uses something called the OFDM. All right, the OFDM, the orthogonal frequency division multiplexing. Anyway, yeah, I got that right. Anyway, I got that right. So it uses that to for its communication. So it is a more efficient coding technique. That splits the radio signal into several sub signals after they reach the receivers. Okay. So with this, it greatly reduced interference. Okay. With this particular, with the OFDM, it greatly reduced interference. So you don't easily have issues with that. Now, after that was done, okay, after that was done, there is another one that was designed, that was manufactured, which is the 82.11G. The 82.11G has the ability, okay, to transmit. It transmits 2.4 gigahertz, just like the 82.11B. It transmits 2.4 gigahertz, but it's a lot faster than the 82.11B. It's a lot faster than that, because it can handle up to 54 megabits per second. All right, it can handle up to 54 megabits per second, and it also uses the OFDM. Okay, it also uses the OFDM technology, just like the 8211A. All right, it uses that. So that's because of that technology, the OFDM technology. That's what makes it faster than the 82.11B. Okay. So the next one after that was the 82.11N. All right. Now this one, I think it was introduced around 2009. It was introduced around 2009, and then it kind of though some people say it's backward. All right. Some engineers said it's backward anyway, but based on what I've done work with it. It's a little bit fast. Okay, it's a little bit fast. So don't they say it's backward anyway, but it's kind of compatible with the 82.11A. It's compatible with 82.11B, and it's also compatible with 82.11G. Okay. So it has a great significant improved speed, okay, and range over the other ones I've mentioned. All right, it has its speed is greater than the other ones. Okay, so when others are like, for example, the 82.11G is talking about 54 megabits per second. All right, now the 82.11N is talking about 140 megabits per second. Well, that's fast. So most of the devices are now using the 82.11N because it's able to transmit lots of information. Like it's very fast, very fast. So, and this gives you ability to transmit data in up to 4 streams. Okay, you can transmit up to 4 streams of data each having a maximum of about 150 megabits per second, and it's very fast. It's very fast anyway. It's very fast. So that's the 82.11N is an improve of the other one. Now, coming down after that, the 82.11.11n. Now, around 2014, that's 2014, not too long ago. Now, the 82.11.11ac came out. All right, and this one is exclusive at 5 gigahertz, like very, very fast. All right, very, very fast. So it's faster than the 82.11n. It's faster than that. When 82.11n is talking about, when we're talking about 150 megabits per second in 82.11n, now the 82.11 AC is talking about 450 megabits per second. All right, on a single stream. So it sometimes goes to gigabits per second. Oh. It sometimes goes to gigabits per second. It's very, very fast. It's very, very fast. So it is now because of this, a lot of devices make use of it when you're looking at something that needs very fast reception, very fast control. You go through that. Then sometimes the reason it's called sometimes the reason it's called 5G. I'm talking about the 82.11 AC. Sometimes the reason it's called the 5G is because of its frequency band. Okay, it's purely based on 5G. But sometimes, like I say, it goes up to gigabit because of its potential to exceed a gigabit per second on multiple streams. And sometimes it uses very high throughput protocols anyway. That's the VHT, very high throughput. So sometimes it uses that anyway. It's super fast. Now, after that, there is another one that came out in 2019. 2019, the 82.11ax came out in 2019. This one is way fast. I've not really make use of this one yet. I'm really planning to make use of it to do some experiment with it and see how what extent it can go. Well, I'm not really done an experiment with it. I've done experiments with the rest. So now this very one came out around 2019, and then its ability exceeds that of the 802.11 AC. It exceeds that. Its ability exceeds that. So now, when 802.11 AC is talking about 450 megabits per second, this one is talking about 9.2 gigabits per second. Like fast, like very, very fast. 9.2 gigabits per second. Oh, that's fast. So it helps you do a lot of things in less than no time. Before you know it, your communication, you're done with what you are doing. So and now it is and this very one uses 6 gigahertz. So this very one uses 6 gigahertz. Though it somehow uses 5 gigahertz, but most time it's there's just one device I've seen that uses 6 gigahertz, and then according to some write-ups, they say it's able to acknowledge that anyway. So, but there is a proposed one which is to come up by 2024. Okay, there's a proposed one which is to come up by 2024. So I'm still putting my eye crossed to look at it, but some of the things they said about it, they said it's going to be way faster than the 802.11ax. They said it's going to be very, very fast. So, and then this very one, they call it 802.11be. All right, 802.11be. So they said it's going to be done. It's going to be released by 2024. That's just some documentary I saw about that, and then it's going to be very very fast. So well, some say that it's going to, they said it's going to be of Wi-Fi 7. All right. So the AX, that's the AX series is called Wi-Fi 6. All right. The IX series is called the Wi-Fi 6, while the AC series is called Wi-Fi 5. All right. So this very one, the BE series that is going to be produced, say 2024, they said it's going to be called Wi-Fi 7. That means some phones won't have access, won't be able to won't really have access to it, because I think there are some phones that are still on the 2.4 gigahertz network. There are some phones down here in Nigeria. Yeah, there are some phones that are still on that. And then there are some devices that you want to work with, and then you can do. Or like my Android phone is operating on 2.4 gigahertz. So there's some high tech device I want to do. I have to switch to either a PC modulator, or I have to use my other phone to work that out. So this all these depends on what you want to use it for. All right, what you want to use it for, and what's going to be the device, what's going to be the data, what's going to be the size of data you'll be exchanging in a second. So we want to know the type of data you want to exchange in a second. That's what is going to help you know the type of Wi-Fi you in which you have to use. All right. So now we are done talking about the 802.11 D, G, and N. So unfortunately, a device doesn't have the E series. Okay. So this is just for the ESP8266. There are other versions of ESP that has a series of this Wi-Fi. Okay. Some of them has Wi-Fi 5. Right. So you need to know which one you want to use, so that you need to know which one is really best for your package anyway. But for simple let me just say simple house stuff, you can still use the ESP8266, still 2.4. If what you want to switch is just basically switch on and switch off. You just want to toggle, maybe just want to use toggle switch or something, not much. You can still use the if you can still use the B version or G or N version of it. Okay. So moving forward, now the next specification on our table here is the Wi-Fi Direct. So it has a Wi-Fi Direct, which is either P2P or sub AP. Now I'm not going to deal much on this AP or P2P here. I'm going to talk about that in the next slide. But this P2P just means peer-to-peer. All right. So you just have one device broadcasting and then one device connecting. That's just peer-to-peer. A very case example is Xender. All right. So when you're about sending a file using Xender, what happens is this is Wi-Fi. All right. It gives the person sending, okay, serves as a hotspot, okay, and then the person receiving uses a Wi-Fi to receive. That is uses a client mode. So we have a client mode and a server, or a kind of an AP mode, okay, which is the access point mode, and then we have the standard mode anyway. So it depends on which one you are using. If you are okay, it has the session mode and the access point mode. Okay, so if you are the one sending information, you're using access point, okay, in which your device is now broadcasting and other device connect to. But if you are the one receiving, you're using a session mode in which you are now connecting to a broadcast Wi-Fi. All right. So like I said, it's integrated. This particular ESP8266 has an integrated TCP IP protocol stack. I talked about that. It has a TR switch. It has LNA. I'm going to talk about that later on, which has to do with the power amplifier and also some other matching network. And then it has an integrated PLL and then regulators. I want to talk about that when we get down to the architecture. So let me not take more time on this. I'm going to talk about this extensively when we talk about it in the architecture. All right. So it has some power modes and everything. So it also has an integrated ultra low power power 32-bit microcontroller. Now, not all microcontrollers, okay, not all microcontrollers has uses this thing 32-bit. All right, so it's kind of what am I saying? What am I saying? It's very fast. Okay, like Arduino is about, is it 8-bit? Arduino is 8-bit or so. Arduino Uno, I think it's 8-bit or so. So it's a little bit faster in terms of processing speed than that of than Arduino. It's a little bit faster than that of Arduino because of this 8-bit processor. I'm going to go in depth into the processor so that we talk much about, we look at that activity. Okay. So now let's look at the connectivity. All right, let's look at the connectivity. How does it connect? So it basically has two methods. All right. So like I said, it has, this is ESP S260. This is the Node MCU. All right. This is a Node MCU version of it. Okay, this is ESP32 version. All right. This is not MCU. All right. So now, what happened is that it has two modes, either access point or session mode. All right. So you choose which one you want to use. Okay, depends on your configuration. Okay, say you're designing for a house. Okay, and then you have to choose which of the mode you want your device to work on. Is it going to be an access point mode or is it going to be a session mode? Now, in the access point mode, the Wi-Fi, the ESP broadcast, okay, it's like a hotspot, okay, it acts like an hotspot, and then it broadcasts signal, a Wi-Fi signal, either Wi-Fi 2.2 or Wi-Fi 5 or Wi-Fi 6, depending on what model the Wi-Fi signal is. So it broadcasts that, and then every other device can connect to it. So you can, for example, when anytime someone comes into my house, there are always a lot of Wi-Fi, because there's a Wi-Fi for the socket, there's a Wi-Fi for the fan, all of them are broadcasting. Okay, so when I want to do something, I just pick up one and then I'll work extensively. I can just go to a particular one and then work in it. And then you can create a hub. When I talk about a hub, is that you can have a point where other components, okay, connect to it, and then it connects to others. All right. So like example, you have a node, and then maybe let's just say you are designing something, a smart city. Okay, let me go back to that. Let's just say you're designing something for, let's just say, a smart city, and then in the smart city you have different flats, okay, or different assets, and then in those assets you have let's just say you have the block. This is the first block. All right, let's just say this is the first house. All right, and then so let's just say this is the first house, and then we have another house somewhere here. Okay, this is another house. Okay, this is another house. Okay, don't mind my drawings. And then you can make it in such a way that this one becomes a node of its own, and this becomes a node of its own, and this node can be controlled can be seen as the central control. So let's just say this is the saver of the whole estate, okay, the whole estate, and then it's seeing this is node A, okay, which is the house, maybe the house I'm living, or maybe the house someone here is living, and this is node B, some other person is living in this other house. So now the person at the central control, okay, which is with the central control, which has maybe the saver, can have access to what is happening at node A, and can also have access to what is happening at node B. So maybe, for example, there's a fault in node A, so the person in the central control can see what is happening, what the fault is, and can trigger that off. Or for maybe, let me use a real scenario. Node A has not paid his utility bill. Okay, maybe the water, the light, or the gas has not paid his bill. So what happens? This particular person here can switch off this particular node, or I can switch off the entire everything in this node so that it doesn't have access to power since it didn't pay for the power. It's gone, or switch off this one without affecting this one. So whenever the owner of node B comes out, the owner of node B only interacts with what he has in his house. Maybe the fan is in his flat, the fan that is in his flat, the AC that is in his flat, the water heater, the lighting points, the window blinds, the door, the gate. The owner of node B only interacts with node B, but the owner of node A only interacts with node A. But the person working at the table can interact with node B, can also interact with node A. All right, so you can make it at that point where you can make it as a node where other people connect, other things connected. So you can set this one to be, you can set this to be any of these. It depends on what you want to bet. If it's going to be, since it is an onboard antenna, it may not really go that far. Okay, so you have to look for a device, an AC that has an external antenna, so it can go, you can have a wider coverage. So like I said, the access point broadcasts Wi-Fi signal, and then the other one, every other device serves as a client, and then they receive it. So you can on the ESP, you can host a mini web server on the ESP, okay, and every client can have access to it. So every other client is a session, every other client is a session, and then they're connected to it. Then the other way you can connect, you can use an ESP is in a session mode, okay, where you connect it to, where you have the central session, okay, and then every other device connected to it. Like this can be your router, okay, whatever device, whatever router you're using, this can be your router, and then it's connected to it, I connect to it, it connect to it, it connect to it. So now, if you're using it as a router, this is the thing, okay, this is the advantage if you're using it as a session. Now, this client can have access to this through the router. This other Wi-Fi client can have access to this through this Wi-Fi, through this router. But here at this point, if you want to have access to this one can have access to this. You don't want to have, you also have to connect to the same network before you can have access to this. So now, but when once you connect to, you need an IP address of every, you need an IP address of everything. But here, adjust this one. When once anybody have access to this router, okay, anybody that have access to this router can have access to this ESP, have access to this client, and have access to this client. So anytime I come back home, first thing I have connect my phone to the main router in the house. Okay, when I connect my phone to the main router in the house, I can talk to my phone. Okay, if I'm not close to my Google Home, I can just talk to my phone, and then it goes straight to this router, and then there's a technology called MQTT. Okay, there's technology called MQTT. We're going to talk about that later. It's also a protocol in IoT. Then I'm using MQTT. So when once I talk to my phone, and then it uses a post connection whereby you publish and then you subscribe. So any device that is not subscribed to that particular topic just doesn't listen, doesn't hear what I'm saying. But any device that is subscribed to that particular topic listens to what I'm saying, and then can take an action. So you can set it as an access point, or as a session, as a session where you connect to a device. So when you're connecting it to a device, okay, when you're setting it as a session, you need the SSID, okay. You need the SSID of the device you are connecting to. All right. You need the SSID and the password if it's protected, okay. You need the SSID and the password of the device you are connecting to. But if you are using it as an access point, what it's going to do is just going to broadcast an SSID, and then every other network will connect to that SSID and with its password. All right. So maybe you can choose to put a particular password on it that other devices will connect to, and then you may choose not to put a password on it. You can make it open for other devices. You can just make it open, so anybody that has the SSID will just have access to it without without security. But I always say, always make your device secured, because you don't want anybody coming and having access to your device. So now, SSID is just an acronym that stands for is an acronym that stands for Service Set Identifier. Service Set Identifier. So it's in other words, it's your Wi-Fi name. All right. So when you're using your phone as a hotspot, you just turn on your hotspot, and then someone is connected, and you say, "Hey, what's your Wi-Fi name?" Now, technically, that is your SSID. Okay. So when someone asks you what's your Wi-Fi name, just say them, "Oh, my SSID is this." So that's the SSID. So, and then you can choose to secure it. I'm going to talk about it in different mode of securing it in the next class. So I don't make this class kind of I don't bug you in this particular class. Okay. So you can choose to protect it. You can choose not to protect it. It's just you have the choice. All right. So there's a different way of protecting it, and you can also make it free and open for anybody to have connection to. Okay. So it all depends on what really you want to use it for. So you have the different mode of protecting your Wi-Fi. That's keeping it private. Okay. It has the WP. It has the. Let me see if I can write this here. Okay. Do I have something to write? Okay. Okay. I don't have something to write. So it has the first one is WP and then WPA2. Okay, so this is the first that's the first way that's the first method of how you can protect it, and then it stands for Wi-Fi Protect Access version 2. All right, so we are going to talk about it later on. That's just Wi-Fi Protect Access version 2. Now there is Wi-Fi Protect Access version 3, and there is something called Media Access Control MAC. You'll be hearing people talk about MAC address. What's a MAC address? So the MAC basically actually stands for Media Access Control. So that's a MAC address anyway. So we are going to talk about that deeply in the next class we'll be having. Okay. I hope I'm not losing anyone. Please, if you're following me, can you just give me a thumbs up so I know I'm not losing anyone? So just give me a thumbs up or just drop me a chat or something, and I'll know that you are following me. Okay, Victor, I've seen you. Okay, that means you're getting me. All right. So if you're not getting me at any point, please just drop a question on the chat button, and then I'm going to look at this, and then I'm going to answer that. All right. So let's proceed. Okay, so now let's move into the next, and then let's talk about the architecture. All right, let's talk about the architecture of this very device. Well, the architecture is broad. Okay, the architecture is broad, and then I'm going to see how not to take too much time and see how I can do justice. Just trying to see how I'm going to do justice to it and not deal too much on it. But as time goes on, we are going to be looking at, we are going to work, we're looking at it, and then we are going to be making use of it, and then you're going to understand a whole lot of things. Okay, so now let's talk about this architecture. So this very device, ESP8266, Now they are different. The other ones, they are ESP32, ESP1, and other one. So this architecture is based on ESP8266. All right. Well, I don't think there will be time for us to go through lots of architectures of microcontrollers or Wi-Fi modules. So I'm picking this up. So like I said, it's 802.11 BG and then for the N series, the N series supports 2.4 gigahertz. I can transmit up to it can transmit up to 72.2 megabits per second. All right. It also has the fragmentation. It also has two virtual Wi-Fi interface, and it has an automatic beacon monitoring, and it can be used for BSS, or it can be used infrastructure, and also support AP, and it also supports promiscuous mode. All right. So when we pick each of it, I'm going to deal much like we're going to pick one after the other. Now the sub AP is the one I was talking about, the access point. Okay, that's sub AP mode I was talking about. So for the BS session mode, I'm going to talk about that later, and then I'm going to talk about the promiscuous mode anyway. All right. So there's a way you can set, before I continue, let's forget, there's a way you can set your device, okay, to work both ways, in the sense that, for example, you develop a product, okay, and then in your code you've written, if you want to be hard coding, what I mean by hard coding, that means the SSID and the password are included in the code. Okay, if you want to be hard coding SSID and password, it's not going to make your your product marketable, because, for example, you put in a particular Wi-Fi name and a particular password, and the person takes it to his house and it doesn't have that Wi-Fi name and password. What will happen? It will not be able to connect. So what happens is that you can make your device work as an access point first. Okay, so making it in such a way that, for example, maybe it's okay, so you can make it work as an access point first. So when it works as an access point, you can write a program into it that broadcasts a particular Wi-Fi, and then it has a certain saver, a certain web page on it. So when a user picks it up and then turns it on at first time, the device can broadcast, can set itself as access point, and then the user connects to it and set a certain SSID and password he wants. And then the device can also all these smart devices. That's how they work. Okay, Google Home. That's how Google Home works. Alexa. That's how Alexa works. And a whole lot of them. A whole lot of like maybe Soya smart switch, Soya smart sockets, Soya smart lighting. Philips. Those are smart. Those are people. Those many names I mentioned are those names of people that are really IoT giants anyway. So Tuya, Philips, and there are a whole lot of them there. Now, let me just digress. There is okay. Well, we'll come back to that anyway. We'll come back to that. Let me not go there. Let me not go deep in it because of our time. Okay, so for the certification of this particular device, it's Wi-Fi Alliance. Its certification is Wi-Fi Alliance. Okay, so it has different protocols. That the protocol I mentioned, 802.11b/g/n, and the case will be. So frequency range is from 2.4 to 2.5 gigahertz. That's the frequency range, and then it has a transmission power. Okay, I remember I told you I was going to talk about transmission power. Now it has a transmission power. This very one, the transmission power cut across the B version of 802.11b, the G version, the N version, as I can. So for the B version, it has the ability to transmit up to plus 20 decibel. Okay. it has the ability to transmit up to plus 20 decibel a meter. And then for the G version, it has the ability to transmit up to plus 17 decibel. And then for the N version has the ability to transmit up to plus 14 decibel. Then for its receiving sensitivity, it has okay, well, maybe sometimes you can let me not go through that. You can just go read about that. It's data sheet. I'm going to drop this data sheet on the channel, Wi-Fi channel, so you can on the Slack channel, so you can also read about that, and then you can ask me questions based on that, the particular data sheet, if you have any question based on that. Okay. Excuse me. All right. So for the antenna, I said some of them have onboard antenna. Those are PCB trays. Okay. Like the one we saw previously has an antenna on it. So let me just see if we can take a look at this. Okay, this very one. So this very one, it has an onboard antenna. Okay, this is a PCB tray antenna. Okay, so this is the antenna. K2, this is the antenna. All right, so it has an onboard antenna. All right. So some of them has an onboard antenna, some doesn't have an onboard antenna. So it depends on which one you need. Some of them use a ceramic chip for its antenna. Some of them use a IPX for the antenna. Some has an antenna. It depends on which one you need. Now, let's talk about the CPU. All right, let's talk about the CPU. Now, this CPU is a 32-bit Tensilica. This CPU now is a 32-bit, okay, Tensilica L102. Okay, so it's a based on that processor. So it's a little bit faster than Arduino. It's a little bit faster than Arduino, because Arduino is based on it's an Atmel 328, that's 8-bit Atmel 328. So it's a little bit faster than that of Arduino. So on a pin, that's a lot of peripherals. Okay, that's a lot of peripherals interface, like the UART. Okay, these are the peripherals interface I'm talking about. Okay, these are the peripherals interface I'm talking about. It has the UART. It has the SDIO. Okay, I'm going to talk about the SDIO later on. It has the SPI. It has the I2C, has the I2S. Now, I2C means inter-integrated circuit. Now, I2S means inter-integrated sound bus. Okay, so I2S is for sound, and then I2C is for other stuff like that you want to use. Then it has some of it has space for IR for that for remote control, and then it has GPIO pins. All right, GPIO pin has GPIO pin, and then I have a message here. Okay, I don't have a message here. Okay, so it has some of them has GPIO that's GPIO pins. They have ADC here. Okay, ADC means analog to digital converter. And then they have a pulse-width modulator. Some of them have pulse-width modulators, meaning you are able to interface analog signals with them, as the case may be. Some of them has a LED button, and the case may be those are the peripheral interface. Now, coming to power, it takes 2.5 volts to 3.6 volts. All right, it takes from 2.5 volts to 3.6 volts. But from my experience, if you give it anything less than 3 volts, you're going to have issues in communication. From my experience, I've used it a lot. If you give it anything less than 3 volts, you're going to have issues with communication. Like you're going to the reception is not going to be that strong. Okay, transmission is not going to be that strong. The power is not going to be that strong. It's not going to be that good. So it's better you give it from 3.3 for my own safe range. is always from 3.3 volt to 3.5 volt. That's my safe range. Okay, you can't really go outside that. Now there are some that you can go above 3.5. There are some that you can go above 3.4. So before you even start working on any ESP, get to know the data sheet and the power in which it can take before you fry it up. I remember the very first time I started working on IoT. I think I bumped up to 10 at the stage. Like I bumped a lot of them. Yeah, because I was just making experiments to know to be sure. Although I knew the input voltage, that I just needed to be sure. Okay, I just needed to go that extra mile. So I think I blew about I blew about 10 of them. So that's what gave me the experience of how really this thing works. Okay. So the current is about 80 milliamps. It's very small. It has a very small current consumption. So you can power it on and then leave it on for a long time. You don't really have issues. Okay. It has a very small current consumption. And then okay. Then its temperature is from minus 40 degrees Celsius to about 135 degrees Celsius. So, but just try to keep it at a certain, just try to keep it minimum and don't try to, just try to keep it minimum so you don't have issues anyway. Okay, so for the Wi-Fi mode, it can this very ESP works in three modes. Okay, three mode Wi-Fi mode. The station mode, the soft AP, then soft AP and station mode. Okay, when I talk about soft station mode, it's working on it's connecting to a device only. All right, that's the session mode. It's connected to a device only. Then the soft AP the soft AP mode means that it's broadcasting and other devices are connected to it. Now, then the soft AP mode and the session mode means that it can broadcast and to other people to connect, and then it can connect to other people. So just like you having a router at home and have a Wi-Fi device at home, and then you have a modem. So you connect your modem to it, and then the modem picks the router picks data from that connects to another device and then broadcast that's the rebroadcast. Let me just call that rebroadcast anyway. So you can use that. Your laptop does that can do that. While you're creating a hotspot for others to connect, you can also connect to another hotspot anyway. All right. So it has encryption. Okay. When I talk about encryption and security, I'm talking about the WPA. All right. I'm talking about the WPA. When I'm in the WPA, I'm talking about the Wi-Fi Protect Access version. Okay. So it has that, and then it has the Protect version, Wi-Fi Protect version. It has Wi-Fi Protect version, Protect Access version 2, and then it has the way it has other exceptions anyway, in which you can also look at. Now it has an upgraded firmware. It runs on a firmware in which maybe when you get into intermediate parts, okay, these are the beginners part. When you get into intermediate, we'll talk more about firmware, and then we'll get to understand what firmware is and how you can build your own firmware. So it supports cloud servers development, it supports firmware and SDKs, it supports fast on-chip programming, and it uses IPv4 protocols. It makes use of TCPs, it makes use of UDPs, makes use of HTTPs, and then the user can configure it. Talking about the 80 instruction state, the cloud server state, and maybe Android, iOS app, depending on how you want to, the user wants to use it for. So now, talking about this VERPing, I'm going to talk about this one now, and then hopefully time is going to allow us, but this time doesn't allow us. I'm going to drop it on the channel, on the Slack channel. So let me quickly just talk about this. This is the main chip. Okay, this is the main Wi-Fi chip. So when I talk about the main Wi-Fi chip, I'm talking about D. Okay, I'm talking about D. Okay. Oh, go back. No, I need to go back. Back. All right. I'm talking about this very chip that is on board. My pin. Okay. I'm talking about this. All right. This is what I'm talking about. Okay. That's what I'm talking about. Okay. All right. So that's the main chip, and let's see how we can. Let's just try to talk about this very chip. Okay. Okay. So the very first one there. Let's start from pin number 1. Okay. From here, with this way you have a pin number 1. Okay. Hope you can see this. This is your pin number 1. So let's start. Let's see how we can start from pin number 1 and then come down to pin number 33. Let's see how we can talk about it briefly. Okay. So for pin number 1, the pin number 1 is the UDDA. Okay, which is for power. Okay, and it's for analog power, which is which ranges from 2.5 volts to 3.6 volts. All right. Now the LNA. So this LNA is for input and output. All right, it's for input and output. And then it makes use of this RF antenna, okay, interface, and then which uses the chip on board having an impedance of about maybe 39 plus or 39 plus 6 around that anyway. So it's kind of match. It's kind of N type or kind of pi type a matching network to match a kind of a specific antenna in which you use. So like you can see, it goes through that, and then any of these, and then it transmits to this particular antenna. So it goes to that. Now the VDD 3P, the 3Ps, this pin 3 and pin 4 are for power. Those are power amplifiers. Okay, those are power amplifiers, and then they take from 2.5 volts to 3.6 volts. Those are power amplifiers. Then this very one entity, this is at pin number 5, is normally leave at most time at normally closed. Okay, not really in use. So for the next one, the pin 6, which is the T out. Okay, the T out is an input. Okay, it's an input pin which has an ADC attached to it, that's analog to digital converter. It has this attached to it. So what happened here is that it can be used to test the power supply voltage of pin 3 and pin 4. Okay, so it can be used to test the power supply if the power supply is okay or not okay. It can be used to test the power supply at pin 3 and pin 4. And the input power voltage of pin and but so it can be used to test that. So but the thing is, it cannot be used simultaneously. Okay, it cannot be used simultaneously. Did I use it for testing one or just whatever? You can use it simultaneously, test 2 things at a time. So it's just only one. It's just a single use anyway. So for the chip enable, which is which is at pin 7, the chip enable now, when you this chip enable is left high, okay, when you are working on it, okay. When the device is working properly, okay, you leave it high. Now, once you leave it low, the chip goes to sleep, and then very small power is consumed. So when you're designing a device and then you say okay, there should be an inactive period. An inactive period is when the device is not really in use. Okay, so what happens? You should go to sleep and not to use your power, just like a laptop or your phone. When not in use, what happens? The screen goes off, something goes off, and then something doesn't really work. But there are some things working at the background. Okay, so that's what happens. So when you want to put it to sleep, you just set this pin to ground, and then you put it to sleep. Now the next pin is pin number 8, which is the TPD and DC. So this is it's an input output pin anyway, which can be used for deep sleep wake up. All right, it can be used for deep sleep wake up, and it can somehow be connected to GPIO 16 or GPIO 16. Okay, not really. So this is 402. Okay, not really. I mean, I didn't include that. All right, so it somehow works with GPIO 16. And then the next one is the pin number 9 is also input and output. Okay, input and output, which can also be used for that's clock for SPI. Okay, now when you talk about MISO and MOSI, that it can be used for that. It can be used for that. Okay. I think I have someone. Okay. All right. So now I'm going to drop this particular. I'm going to pause here for questions. So I'm going to drop this link. I'm going to drop this presentation for you and the Slack channel. So you go through it. If you have any questions regarding this, please you let me know. I'll always try to make a time to talk about it. So let me just jump from here and talk about just simple ways of what it can be used for. It can be used for home appliances. It can be used for home automation, for smart plugs, for smart lighting, industrial wireless control, bay monitoring, IP cameras, sensor network, wearables, Wi-Fi location awareness device, security tags, Wi-Fi operation systems, beacons can be used for a whole lot of things. Okay, so here it depends on what you want to do. The first thing is about, like I said, the first thing is for you to know what you want to do and knowing the components you want to use it for, you want to use to working that out. So I'm going to stop here for today, and then I'm going to open up for question and answer. Or if you have any question regarding this particular class, please just I'm looking at the chat now. Just give me some either thumbs up or some or you drop it at the chat button, and then I'm going to. We have just 2 minutes to do that, and then please, if you have any questions, just let me know so that I can answer them before we go. So I assume you really understood this topic, or I hope I wasn't too fast, and then I'm okay. Okay, so okay, for the sake of time, okay, of seeing one person. So for the sake of time, let me answer this your question. Let me all questions drop it at the channel, okay, the Slack channel. I'm going to answer that all questions, whatever it is. I'm going to answer it in the Slack channel because of time, because another class coming. So, want to say very big thank you to every one of you that made it to today's class. We're going to say very big thank you to you, and we're going to end here, and then this is me saying goodbye to you next week Monday, and then we'll meet again next week Monday by 5 p.m. So thank you so much for joining today, still drop your question at on the Slack channel, and then I'll go through the questions and then I'll answer your question. Even if you need a session with me, just still drop it there, and then we'll still we'll see how we can make justice to that. So thank you so much, everybody, and have